Hello, dear students. Uh, as you remember, we have already finished the studying on the standard papers, drawing papers, and the title block format, drawing paper format, and content of the title block. What is quadrant symbol? What is the scale format? Into which box the material of the object is written? Name of company, etc., etc. And then, focus the attention in the order to the things to have a paper simulation in Inventor. Yes, having a paper simulation is a must in Inventor environment. Without having a paper simulation, cannot use the view creation tools of software. In AutoCAD, having a paper simulation, if the case is the one gonna use AutoCAD for two-dimensional drawing purpose, not model creation and then view creation, but just using old-fashioned technique, AutoCAD is going to be used just as if a drawing paper, two-dimensional tools, going to use two-dimensional tools of AutoCAD and draw the views, then yes, a good practice to have a paper simulation. It is just to show that which part in the screen is the working area to draw something. First, let us see the things to do for having a paper simulation in Inventor environment, and then focus the attention to the corresponding things to do in AutoCAD environment. Okay, then see the things from my computer, desktop, and Inventor environment. Okay, I open Inventor and say that the solid model is available where in either in the screen or in the memory of the computer. If it is the time to create the views, then yes, in Inventor, since it is going to be a new file in this logic, click on New File Creation button first. And in the dialog box, select from this list. If you found it in this compact form, then click on the listing arrow in the first pane of the dialog box, and then clicked on the other arrow, and then find metric English options. If you're going to create the views as first quadrant views, make the selection on metric option. If you're going to create the views considering the body as located in the third quadrant of the universe, then select English option. Select metric option unless otherwise mentioned, and then for having a paper simulation, make the template selection from 1 to 3, third pane, okay, of the intermediate part. To be able to have the dimensions in ISO format, annotations in ISO format, title block in accordance with ISO definition, make the template selection on ISO option. Extension IDW, just to say that the file, when we create the file, it is going to be in Inventor format. If it is selected ISO DWG template option is selected, then the created file will be in AutoCAD format. Unless otherwise mentioned, please obey to this kind request and select the Inventor format option, ISO.IDW, and then click on Create button. That is it. A paper simulation in few seconds will appear in the screen. Inventor, considering that A3 is the most commonly used paper size, standard paper size, automatically selects A3 size as it is default configuration. Okay, margin lines, and this is the working area. How it is edited? Say that the object is a big object in size, so well it is necessary orthographic views impossible to be fit onto this working area under a certain suitable scale factor. Then yes, this video, since this video is about not how a view is created but how a paper simulation is edited, now well answer the questions. How the size of paper can be changed, how the orientation of paper is changed, and in case how the title block is shifted from its standard place to another suitable corner. Okay, first answer the question how the size of paper is changed. Well, it's an editing issue. You know, the browser in the structure of Inventor, this pane is called browser, is to it is one of the function is to use for editing purpose. So it is an editing issue. Bring the cursor to browser and over there find sheet icon. Right click the mouse when the cursor is on sheet icon, and from the pop-up menu it will drop after right clicking to the screen. Select edit sheet option with a click, and here is the dialog box. Well, if it is the case you need to change the size of paper, then click on this listing arrow and from the list select the other paper size. For instance, need to use not A3 but A1 size paper. From this list select A1 with a click and then say OK. That is it. Now the paper is in A1 size. Whatever the paper size is, pay attention, the size of title block will be the same, is to be the same. Inventor knows this logical fact and keeps the size of title block in the same order. Okay. Why it is so? Because our purpose in changing the size of paper is to have a suitable, for instance, greater working area, to have the images to fit the views. But at the title block, we use daily life language, write the name of company, write the name of object, etc. Well, no need to make the title block bigger in size, because the text can be fit into the available pigeon boxes. Okay. How the orientation of the paper is changed. Some cases may be more suitable to use paper as vertically oriented. In the jargon, say portraitly positioned. For instance, you're going to have two views, column-wise located, front and top views. Then use the paper as vertically oriented. Or say that the height of the object is greater than the other size, it is going to be suitable to orient the paper vertically, as vertically positioned. How the orientation of paper can be changed. Bring the cursor to the sheet onto the sheet icon at the browser, right click the mouse, select edit sheet option, and then not landscape. Landscape is the automatically selected radio button. That's why we find paper simulation as horizontal oriented, but portrait option. And then say OK. That is it. Well, some cases, when we created the views, then one of them at least may coincide with the title block. It is, of course, having such a clash is a poor practice. In such a case only, it is allowed. We can shift title block from its correct location, standard location, it is the lower right hand side corner, to another corner. For instance, in the scenario, assume that we have a clash with the title block and the view. So To be able to prevent interference, shoot the title block from this corner to the other corner. Try upper right corner. How? It is an editing issue. Bring the cursor onto sheet icon, right click, edit sheet, and then select this radio button at the other corner of this paper simulation. And then say OK. Then the title block will be shot from here to there. Yes. Well, here the other case. Standard paper size, as it is biggest basic size, is denoted with code A0. Assume that in the scenario the object is a very big object in size. For instance, it is an aircraft, the model of an aircraft. We have the model of an aircraft, and it is model size is in the actual order. I remember, for instance, aircraft fighter 16 is in the order of, to its length, 16 meters, and A0 size paper, yes, remind you, well, A0 size paper is to its width, if it is oriented as landscape oriented, a little bit more than 1 meter, not 16 meters. And say that in the example, the necessary views to have are not only front but also top and the left. So obvious that under the scale factor 1:1, it is impossible to fit the images over an A0 size paper. Okay, well, A0 is the basic largest size. This does not mean that well, we cannot use an A0 size paper. Well, imagine that we have, for instance, 10 A0 size paper. How? As connected to each other. It is possible to have papers, to use papers and correspondingly have paper simulations bigger than A0. See how in Inventor. It is again an editing issue. Bring the cursor to the sheet, to the browser, and on the sheet icon, right click the mouse and edit sheet. Well, instead of selecting standard paper size from this list, select custom size option. After selecting custom size, then can have height and width boxes in the sheet, edit sheet dialog box. Okay, in this example, say that our printer, not printer but plotter, you know, for a printer, the size limit, paper size limit is that of A0, A3. To be able to take the print out, the plottings over a bigger size papers, need to use plotter. Okay, say that in the example, plotter span of plotter is in the size of 2A0. Okay, into this box, 841 millimeters is the standard size height of landscape oriented A0 size paper. Well, say that 2A0, 2 star asterisk, it is to say that multiplied by 2 is the height of the paper. As the width of paper, say that 6 times bigger than A0. So 6 asterisk size of A0. Okay, and then say OK. Well, here I'm going to change the orientation of the paper, edit sheet, to landscape. Okay, now this paper is 2 times 6, 12 times A0 in size. Yeah, yes, it is an easy thing to do for making such editings. And then, well, complete this demo, create the views of such an object. Well, to be able to create the view of an object using its solid model at the background, well, click on base view creation button. Okay, and in the dialog box, clicking on the search button. By the way, if the solid model file is not the active solid model file, it is not available as an active file in the session, then well, it is necessary to teach to the software where it is. But if the solid model is active in the session, then well, Inventor can automatically detect that it is the case and start the simulation, offers one of the side views for that object. Here in this example, since there is no solid model, active solid model already open in Inventor environment yet, I'm going to, in this dialog box, clicking on the search button, show the address. Okay. In this part of my computer, memory of my computer, I know I have such a solid model. Okay, it is the solid model of Fighter 16. Okay, I indicated its address. And now Inventor started the simulation. Yes, this is one of the side views. I'm going to create the views, just defining not this side but the other side as frontal. At the view creation stage, clicking on the arrows around the orientation cube can teach to the software which side view is to be created as the base view. Clicked on this arrow and then rotate the model at the background about the vertical axis through 90 degrees. Clicked on this about the horizontal axis through 90 degrees, or clicked on the banded arrows, rotated about a perpendicular axis with respect to the screen. You know this. You know the function of orientation cube. Here, making such rotations and directing the selected frontal side of body as parallel to the paper can teach to the software that it is the front side view. Okay. I'm going to create the views under scale. Yes, scale factor. This is to say that 20 times smaller than the actual size of the object. Not 20, but try 1 to 10. Yes, assume that, I hope, this scale factor, no, not 1 to 10, but say that 1 to 15. Oh, 1 to 15 is the scale factor. This is the front side view. And then, well, move the cursor in this direction to say that it is the place for the top side view. Move the cursor in this direction and make a click to say that it is the place for the profile side view, front, top, left. Style button in the dialog box must be the first style button from the left. This is to allow software to create not the views of visible but also the views of hidden entities as well. Okay, and then clicked on OK button. Yes. Created the views. Of course, the following stage for this assembly, just to indicate the identification balance of the components and overall dimensions and location dimensions as well. Dimensioning part will be subjected later as in the content of one of the chapters of this course later. Here, just this video is to demonstrate how the size of paper can be changed, how the orientation can be changed, etc., and how the size is customized. Well, remember, talking about the content of this presentation and classifying the views as detailed views, assembly drawing, already studied on this presentation, this part of the chapter, and one of the slides you remember, it is to say that whenever the size of the projection is not suitable to be able to explain the shape of and providing the size of some tiny entities, little entities, then it is allowed. It is the common practice. Well, specify that region using a circular boundary where we have the images of the tiny entities, and for this part make a zoom in, create the views of the part of the object, views of the entities at the part of the object, while under a greater scale factor. Well, here is the created zoomed projection. It shows only the part of the object where we have tiny portions. It is called detail view, okay? Only for detail views it is allowed to use a different scale factor. For all of the other views, principal views, these are what front, top, left, right, back, right, bottom, and also auxiliary views, whatever the scale factor it has been used for the base view is, then the scale factor for all of such views must be the same. But only for detail view a different scale factor can be used. Yes, logically obvious that a greater scale factor. Now, after reminding you on such definition and the meaning, then in Inventor make a demonstration how a detail view can be created. Okay, later I'm going to answer this question in AutoCAD environment as well. In Inventor, clicked on this creation button, view creation button. It is as it is written for creating detailed views. After starting the process, then, well, show the view on which view you have the region to show the content of things under a greater scale factor. In this example, say that it is on the front view. A part on the front view is to be shown under a greater scale factor. So move the cursor to the vicinity of this view and then with a click indicate. After indicating the view where the region is defined, okay, select the scale factor in the dialog box for having a zoom in. I'm going to create the selected part, okay, under scale 1 to 1 in this example. It is a common practice to bound the region where we have tiny entities to show their images under a greater scale factor, a circular fence, okay, bound the region with a circle, and smooth circle, make the selection on this and that. And also, if especially there will be more than one detailed views on the same drawing sheet, okay, to be able to help the reader which region corresponds to which detail view, it is recommended between the region and the corresponding detail view have a joining line. For having such a joining line, select these two boxes and then the rest. Do not click on OK yet. Bring the cursor to the region. Yes, for instance, there is something over here to show it under a greater scale factor. Okay, in this example, assume it is this part. Make a click to indicate the center of the region, and then move the mouse in the radial direction. While doing this, a circle appears in the screen and can be greater and greater while the cursor is moving. Okay, make the circle great enough to be able to bound the region where you have something to show it as image under a greater scale factor. It is this part in this example, and then click your mouse, and then the rest, move the mouse to a suitable cursor to a suitable empty place. Okay, and then locate the view over there with a click. Yes, that is it. This is the joining line, and this is the corresponding detail view. Okay, and over this detail view, if there are some dimensions, of course, can show them. Okay, well, if the space is still available to make the detail view, to have the detail view greater size, then yes, how a view, already created view, is edited, bring the cursor to the vicinity of the view and double click the mouse. It is to call the same view creation dialog box back to screen. And scale factor, not 1 to 1, but I'm going to say 2 to 1, 2 times bigger, and then say OK. Yes. Okay then. Dear students, thank you for your watching. Stay healthy.